Hey guys, and welcome back. So this video today is going to be fairly short. We're just talking about key features of exponential functions. You will be labeling key features of exponential functions in your assignment for today, so it's pretty straightforward, pretty easy. I don't think you'll have trouble. Probably since it's so new, you may have trouble, but I think you'll be okay. So, exponential key features. First, what are they? Y-intercept, the initial value, the a, remember we are using y equals ab to the power of x. So a is my y-intercept, initial value, where the problem starts, the intersection through the y-axis. Domain, all possible x values from left to right. So from left to right. For these, you are going to see some different things, and I will show you what I mean later on in this video, so just keep an eye out for that. Range is all possible y values from bottom to top. And new one, asymptote. An asymptote is an invisible boundary that the graph cannot pass. You shall not pass, okay? So this is just a line that we, as mathematicians, just know is there. I know that it doesn't matter what I do to this graph or function, it is never going to reach that line. It'll get really close, but it'll never reach it, which is just something new. So here we go. Parent function. So the parent function, our domain is all real numbers. Range is y is greater than 0, not equal to, greater. Asymptote, y is equal to 0. It is an equation, y is equal to 0, because it is the horizontal line through 0. So let's kind of label these. And I would write this down. So first thing, y-intercept. It's that point right there. It's where it crosses on the y-axis. Next, domain, I scan my graph. I can see that it is all real numbers because this graph, even though it's going up, it's shifting like this. So it's going out, 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 out. So it's going to keep continuing off to the side. So that is, and of course the other side is just going off to the other side. So it is all real numbers. That graph is never ending. So this is my domain. Get rid of all of that. Next, we have our range. So that is bottom to top. Scan my graph. It's all of this because I can see that graph is going to continue on. So that is the range. Get rid of that. Okay, and last, asymptote. So it is this dotted line. Okay, so now, why is this graph never going to equal 0? The answer is because when I have, let's just use, for instance, y equals 2 to the power of x. It doesn't matter what I put in that x value. It's just going to become a smaller number. It's not going to ever be 0. 2 to the power of 0 is 1. So it just continues on. 2 to the negative 1 is 1 over 2. 2 to the negative 2 is 1 over 4. 2 to the negative 3 is 1 over 8. So it's always going to continue to get really small, 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 small. But it's never actually going to be the value 0. Okay? That is a super important concept. If this graph is shifted in some form, up or down, then you have to assume, or we know as mathematicians, that this asymptote is also shifting because it is a part of the graph. Like that's that line that it's never going to cross. Okay, so I know that if I shift my whole graph down, that asymptote also needs to move down. If I shift my graph up, that asymptote moves up, and so on and so forth. So just have that in mind. It's just something new. It's going to be something that you will get used to, and you do need to memorize. So find the domain and range of this piece of graph. So with exponential functions, the one thing that you will be tested on the most for domain and range is just a piece of the graph, a piece of the picture. So you're not even finding the whole thing. You're just finding that little piece. So, of course, I'm always going to start with my domain because x values, I just have a habit. So I can see that I'm starting closed circles. I'm starting from 2 and I'm going to 6. and these are all my x values. So 2 is less than or equal to x, which is less than or equal to 6, because it does equal on a closed circle. Next, my range. So I can see I'm going from 2 to 8, and these are all of my y values. So 2 is less than or equal to y, which is less than or equal to 8. Remember, the point of finding your domain and range is to just cover all possible x or y values that are on this picture. So on that little piece of graph, those are the only possible values. It doesn't go past that. It doesn't go before that, over it, under it. It's literally just that little piece. And that's really it for that. Okay, so let's go ahead and look at a word problem and finding the range. One of our teaks is that we find the possible domain and range. So what makes sense to this problem. So one thing we always talk about is half-lives. In exponential functions, that's like the best thing to use exponential functions for, or one of them. So a half-life is when, for instance, if we take a Tylenol, when does it start breaking down in our body? When does it start becoming less and less and less and less? And I know what you're thinking. Okay, but I thought these graphs couldn't reach 0. So they don't. And the reason, like a medication, it will never fully be out of your system. It kind of just slowly has those little traces. Like Tylenol kind of stays in your liver forever. So that's why we use these type of functions, okay? But there is a possible range. There is like a range that makes sense. Like I wouldn't go past this. Okay, so the half-life of Tylenol is 3 hours. You take a 500 milligram at 1 p.m. What is an appropriate range after 9 hours? So I know every 3 hours, it's gonna break in half. Okay, so the first thing I would do for this, and really the only thing I would do for this, is create a table. I know my x values are gonna be every 3 hours. My x values are gonna be every 3 hours, so I would just do 1 p.m., 4 p.m., like that. And in fact, I did that. So here's my table: 1 p.m., 4 p.m., 7 p.m., 10 p.m. So at 1 p.m., I've taken my Tylenol, I've got 500 milligrams in my body. By 4 p.m., what has happened, my body's absorbed half of it, so I have 250 milligrams left. By 7 p.m., I've got 125 milligrams left. And by 10 p.m., I've got 62.5 milligrams left. And you know, the normal dosage is every 4 to 6 hours, you can take a new one. So by that point, I have so little left that I can take a new one, but that second dose is actually going to help me feel better because it's starting to build up in my system. That's why it's good to take medicine constantly and not just, and I don't mean take a lot of medicine. I mean, if you're taking something, make sure you take the full dose, okay? So my appropriate range for this would be 62.5, 125, 250, and 500. Remember, we're always going least to greatest, and I have my initial dose after 3 hours, after 6 hours, after 9 hours. And that's all I need. I'm not going past that because they just asked me after 9 hours. So I really don't have to put anything else. This is a continuous, so you could have a boundary of from 62.5 less than or equal to y less than or equal to 500. In fact, that is actually what I would put. I just listed it out so that you could see it. So yeah, I would list that out. 62.5 is less than or equal to y less than or equal to 500. The reason why is because I can measure the medicine at any point in time. So that's continuous, not discrete. Okay, and that's it. So good luck. Hopefully that wasn't as confusing as mud and you get this down.